going to be a Titanic uh, data set, we used to say. So the data set which consists of like those are traveled in the Titanic ship, and let me go into that. Mm, yeah, the data set physically so that you can understand better. Okay, so this is a given data set. Okay, and there are lots of fruitful things which is available in this um, analysis. Okay, so these are the given. This is, so if you ask me, this is a real list of people, though those are traveled in Titanic means, I'm not sure, but this is actually is available a data set to analyze and predict like how many people that travel, whether they're alive or like not. Okay, so surveyed or not, basically. So um, in which actually we have around the given column is 12 column. Okay, and then almost 34,708 34,000, sorry, 3 lakhs 40, yeah, sorry, is this sorry, 1 minute, by mistakenly read that. Yeah, it's almost um, number of rows is 782, 80 rows are there. Okay, by mistakenly we counted this one. So there are 782 records in my given data set. Okay, so here I have what happened. Takes much time. Okay, because the bigger file, that's the reason. Okay, so here I have a passenger's ID and surveyed or not. One is surveyed, zero is not surveyed, and is a passenger's class. We have the 3 different classes and the name of the passenger and the sex, male or female, and the age, and the sibling. Actually, they have all together as a family member. They have traveled along with the in the journey. That one, and this one. Um, so let me check that. Actually, I forgot this one. This one and the ticket number. Okay, all right, and then the fare. How much cost for the fare, and which cabin they have been onboarded, and they were embarked. Actually, there are 3 different locations where they are like they're onboarded for this on the ship. Okay, this is a basic analysis. Just try to understand this is given data set. Now I'm going to what is that? Going to go through that detail, like how they each and every table, the columns related to each other, and finally we are going to be closing this logistics regression topic. Okay, so as I mentioned earlier, just I'm what is it, inputting the required libraries for this analysis, and I'm loading my my database, my data set, and I'm creating the data frame as a T underscore TF underscore data frame underscore Titanic. As you know that this is actually the header. Just I'm giving like getting the data, how it has been like articulated in my Python view, and then here I'm finding like the shape. Shape is nothing but to find out like the number of column as well as the number of rows, row comma column. Okay, and then here just I want to understand how many the people they traveled. So it comes around 781. So even we have seen through that um, what is that, I think this is not okay. So so how many people traveled, like 731, and the dot column, it represents like a number of columns in this specific given data set. And then the info method which used to give that each and every the column, what are the type. Okay, the passenger ID, survey ID, P class, name, sex, siblings, and parents and child, I guess. Yeah, the parents and child and the ticket number, fare, and cabin embarked. See, look at here. Actually, the Python is a very powerful one, and by using that, he understood like the passenger is going to be a integer, and object, and this is also object. So these are very important for your analyzing the deeper analysis. Sometimes we cannot go ahead with the normal object. We need to convert into the proper integer or a float, something like that for analysis. So there are so many things are there. Okay, so we cannot well, like probably like I'll try to articulate that and give us one shot of things like if time permits. Okay, so and here this is also like the cabin and other things also object, so we can convert into the integer or a float or string, whatever if you want we can do that. That's different issue. Okay, and this info will give the complete picture about that given data set. Okay, and what is the size as well. Okay, and then the Titanic is not is null dot any, so it will give that like do you have any, is null means false, false, true. So what wherever we will have the false statement, we'll get that. Even directly we can go ahead and find out whether it is like null value or not. So if you look at that, I don't have anything here, and if you look at here, there might be no nothing, and passenger number, yeah, it's also good. See, most of the given data are going to be like a clean data only, so don't bother about that. So that's the reason actually. Here, good option. See, look at here, blank, right? So obviously, all these things will say like is also blank, right? So the blank data is nothing but like a dummy data. We need to fill that. So probably we'll fill it up later. And same way here also we have blank. So that's the reason actually for the age, yes, and then for cabin and impact, all the details like going to be a true. Okay, if it is true, is null, yes, true. Other things like we don't have any blank column, empty cell. Okay, so this is just easily evident, like we can do that. So there are a few other methods to immute that. So probably I'll take it up later. So we'll go ahead for this analysis first of all. And anyway, here I'm finding the number of count. It's not required anyway. Already we have, just for analysis. I'm doing that, and I'm going to do some um, exploratory analysis. See, for example, if I'm doing is null in any means, I'm getting this the overall picture of the column wise, whether it has any null value or not. But if you look at it in complete row wise, if I since I put the head, since head means it look I'm getting this one number. If I put 100 means I can see instead of instead of instead of this name number in detail, it will directly tell me that exactly true or false. Okay, so this is a one way of presentation, and same way we have the other way to present in the form of graph as well. So we'll see that one by one later. Okay, and then this is one is number of count of how many columns are null. If you look at it here, age, there are 153 column going to be a null. Okay, it's an empty column. And the cabin also, almost 606 columns are cells are null out of 781. These are the very important guys. Actually, see, as a data scientist, applying that data model like the algorithm is just a two-line statement. You need to get that linear regression model from the scikit-learn, and then you need to fit into that your splitted what is that x train y train values, and then you can extract that prediction value. You can put it that 4 line 5 lines maximum, within the 4 to 5 lines we can predict the accuracy, and the you can validate your model. But before doing that your analysis, you supposed to go and deeper analysis of the excel sheet. Like if you give the excel sheet, if you're going to find the number of empty cells under really complicated, and if you want to put something blah 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 thing, it's really a headache. Okay, I'm not able to do that. If it is going to be 700, okay, at least if I'm assigning some task to some data enter operator to fill this, okay, fine. If it is going to be lakhs of rows, okay, if it's going to be lakhs of 35 lakhs of rows means what will happen? The Hindu, any no, nobody cannot fill this one. But if we have this kind of like what is that? If I, since I have the features in Python, the pandas and NumPy, so not directly I can go and fill the values with a simple statement. So before doing your analysis, as I mentioned, you can remember that 80%, 70% of work going to be explanatory analysis. We need to fine tune the data. We need to select the columns. There's nothing but your features. Then you need to fine tune everything, and we need to convert the category into the dummy variable. So many things we have to do. Then only we'll come to the picture of conclusion of, okay, now we can go and apply your model. That's very, very important. So that actually I put a lot of things. See here I could see there are lots of blank here, right? So if you look at it here, it says false, false, and here sometime it's true, true, something like that. But instead of that, if I'm giving the pictorial representation format, I can find out that where it is going to be a null value. It's a fantastic view. Probably like, yeah, after this all remove all the data, look at the same picture will come different way. Okay, so this is going to be most of the things are null, and impact again, there are the few nulls are there, and age, there are so many nulls in it here, and passengers ID, survived, P class, name, sex, sibling, PR, and ticket, and fare. So all these things are nothing there, everything's filled, so that it's completely, you can get the clear picture of this one. So from here you can understand that. So the similar way you can identify that. Okay, so the main important thing, like before applying your model, we have to do all this analysis. It's a very fantastic example, I would say. And here, this is going to be a pair grid, pair plot. I put it up. So how the things are related each other. Look at here. This is totally like you're not able to understand. Not even the scattered plot, right? Not even scattered plot. That is, so come to that. You can understand that is not there is no linear relationship between each other. Okay. Anyways, we'll go ahead. Okay. Now I'm started doing my analysis. How individual variables, individual features are related each other. First time, what I'm doing, I'm going to figure out how many surveyed, how many not surveyed. Okay, so how many people are surveyed? Simply, I'm putting like the count plot. X is equal to my variable, and data set is nothing but my TF Titanic. That's very, very important because I'm going to spend much time on this specific code so that you can understand clearly what is how the logistics working. Okay, how we are going to derive this one, and not only for the logistics, it is applicable for any kind of modeling if you are going to do that. That's very important. Okay, so here I'm just doing like a, single variable surveyed. So the simple diagram, it shows like, what is that? Zero, how many people are surveyed, how many people are not surveyed. If you are going to do it in Excel sheet the different way, I don't know how many of you know this one. Hmm. We need to do the pivot and all. Okay, I don't want to go to the like in detail, but we'll go this one. Okay, so the number of surveyed people, like almost 480 or something like that, and not surveyed, and surveyed the data point is going to be 300 and 280 88 something. Okay, surveyed, not surveyed. Yes or no? And again, here I'm doing how many male or female surveyed detail. What I'm going to pass, there are the two variables. X is going to be surveyed, and hue is one other parameter. I'm going to pass the another variable, another features, nothing but a sex. So how many people are surveyed or not surveyed? We're splitting by the male or female category, right? So these are the bivariate analysis. You can say it's a bivariate analysis. And again, I'm doing this. Okay, clearly there is a trend that looks like a people that did not survive much more likely to be a men. Okay, so there are people not survived. So from this understanding, so what is my conclusion? That the male people, blue, right, the blue legend, So do not surveyed were much more likely to be a man, while some of those who surveyed were twice the likely to be a female. So the surveyed females are like twice than this not surveyed. So the female actually they surveyed much, right? So again, I'm doing the analysis with the classes. So where they the passenger class. So in my given data set, I had what is that now my classes. I have three different classes: class A, class 1, class 2, class 3. Okay, right? Passenger class. So here I'm making the data. Um, one is blue, two is orange, and the three is green. So the same way, not surveyed and surveyed. So looks like the people who did not surveyed were overwhelming part of third class. The most of the people in the third class hugely they're hit. Okay, so as a data scientist, not only you supposed to give the predict model is a, good or bad. Instead of that, you supposed to give the proper data points to your customer. So that's the reason he can understand how we are evaluating, how we are monitoring. That's very important. Okay, they're not surveyed. Third class people not surveyed. The people did not surveyed from the higher classes. Now nearly actually the most of the people that surveyed. So it's like almost equal, but not surveyed only more than 350 almost. Let's say like 350 at 25, whatever it is. So the people there not surveyed in third class is a green one. Okay, and then again I'm doing forget about this one. This one are like the age people. Okay, how many people are totally they're traveled? The age group people. So here it is going to be at 10, 0 to 8, sorry, 0 to 10 is going to be almost 40 kids that traveled, almost 10 to 20. Then it's going to be like a range of 25 people are traveled. Okay, kids are traveled, and age from 20 to 30, there are the people almost 120 people, 140 people are traveled. So it will predict like the most of the youngsters that traveled in this ship. And same way, the other things maximum actually for age more than the 70, almost I would say it's like maximum 10 or less than 10. So the 70 more than 70 ages actually the traveled people population just almost very less compared with either for small kids. So this is analysis is another representation. Forget about this one. Okay, and then the same way here I'm finding like how they are related each other. Okay, siblings, the family members they're related each other. So if you look at this one, right, the not surveyed. Okay, so the most of the passengers are not related to each other. Okay, so the here people are not related to each other, and the relations between them is like really was like not surveyed zero, right? The other things are like very minimal. So the individual people they traveled in the ship, they're not surveyed. The majority of the people they died. Okay, and this is also for some picture representation. Forget about this. Like so for understanding purpose, you can go ahead with that. Okay, so now I'm going to compare with this. What is that outlier? I'm going to find out outlier by using the comparing with my P classes and age. So look at here, the P classes, the class 1, class 2, class 3. The bandwidth, mostly the people in the class 1, almost 30 to 50. These are analysis. Actually, for example, if the customer may not ask you the final product, they might ask you for analysis of the given data set. Okay, what are the data set means something, but what are the things were collected from the different source. So the passengers class 1 and class 2, class 3 older than 3. Okay, so the most of the people they traveled in class 1, they're higher age than class 2 and class 3. Okay, class 3, if you look at here, the people that traveled almost 18 to almost what is that 30, 28, 32. 18 to 38 people, 38 year age between the people that traveled in class 3, and above that almost 25 to 35 the people like that traveled in class 2, and the people mostly 50. The people like maximum the 49, 50 age people, they traveled in class 1. Okay, and these are the high level. For example, there we have seen like few people are traveled in 70, right? So those people are like a few people are in class 2, and so many people more than 70 people that traveled in 3 as well, the top. This is nothing but like the above the range. So from this you can understand that these are the very very key important data point, so you can understand that. But majority what is that, the core going to be only between this range time age range. Okay, that's very important, right? So now we want to handle few things. Okay, um 1 minute. Yeah, cool. Right, I don't want to do this one. We'll go ahead for the cabin. So for this analysis, the cabin, most of the things are blank. So how many things are blank here? I'm not taking much time for this specific scenario because this is a very very important, so that you can very easy and very important thing, so that when we are doing the any other analysis, it will be easy for you guys. So the cabin, almost 606 records are null value. So as I mentioned, replacing with the null value with the maximum value or minimum value or frequent values or nearest value, there are so many methods we can fill that. But if you look at that specific, the to cabin, there are 600 records almost. Out of 780, 600 records means almost 80% of record, like it's a null value, so I cannot fill with that. So what I'm decided, I want to remove this specific column from my data set. So that what I'm doing, drop the cabin access 1 and in place 2, so that it will be removed from my data set. So now my table, it's going to be this one. Okay, and I'm making this one. Still I have few null value in my what, um uh, the other what is that, where we had age na, age or what, embarked, yeah, embarked, we have few things. I'm not going to remove that one. And any other null values, we had a few other null values somewhere, right? Okay, so here how many null values, I think almost what is the number there, the top, yeah. So the only the age I have, uh, 153 null values are there. So what I'm going to do, I'm going to remove that column, so remove the row as itself, so that I'm applying after all clean up the data, removing my cabin and the all other null values. I'm going to check my the data set in picture representation. Now I'm getting clear picture. There is no any dots or slots something somewhere. So if you look at this one, you could see this is the cabin, because this is most of things are null value. So I don't want this cabin for any analysis. So I removed straight away. Got it? It's clear, guys? Clear? You are with me? Yes. So how I'm doing this one so far? Because still we have few more things. Please let me know. Are you clear, guys?
Yes, sir.
Cool. Guys, so that only I can give more inputs from the beginning. I'm telling, so just give your input so that it will be easy for me. Okay. So after removing all the null values, handling this one, I'm getting the clear picture of now I can say I don't want to go back and see my data set like printing here. So I can say here itself there is no null value. Okay, fine. And then see I have the column sex. So here I have a male or female. These are the categorical variables. I want to change the categorical variables into numerical value. Okay. So what I'm doing, I need to handle the string value since the logistic regression looking at categorical values, so that need to be handled those. So instead of having that male and female, if I have the 0 1 column, 0 or 1, then it will be easy for me to handle the situation. Okay, to do the analysis. So further analysis. So what I'm doing, pd dot get dummies of Titanic of the my column is going to be a what, sex. So automatically what will happen? This specific, for the specific column, the function will apply dummy value as going to be a 0 or 1. So for me, female is going to 1, 0 and male is equal to 1. Clear? So in this case, look at that table. After the conversion, the first row is going to be a male, second row is male, third is going to be a male, fourth row is going to be a, okay, this is a female. Okay, let me go and check here. Yeah, correct. So what happened? I have changed, instead of having the male female, because for my analysis I cannot go ahead for the string value. So I want to change into that value is equal to 0 or 1 instead of like for example Chennai, Bangalore, Hyderabad. Instead of having that one, I can make it a 0 1 2. Okay, such a way I'm doing that. So after this changing one, I have one more thing again. What I'm doing, see here I have 0, here I have 1. If I adding this specific column in my I'm going to concatenation. I'm not sure how many of you remember when we are dealing with uh, what is that, serials, right? Series 1, series 2, okay, and if you're merging series 1, series 2, you can merge as here two different series going to be your data frame. It's a one column. Hope you remember. Very long back you did this one. So this is my series. Okay. So, but anyways, if I'm merging this one unnecessarily, I'm repeating all this. Instead of one column, I'm increasing two column in my table. But honestly telling, it's again a headache for me. So that what I'm going to do, I'm going strategically, I'm going to exclude one column. I'm going to keep one, just only one column. How I'm going to do that? See, if it is going to be a female, it's going to be 0. If it is a female, meant 0. If it is going to be male, it's going to 1. Obviously, there is going to be a either 0 or 1. So why I want to keep this two column here instead of that? So what I'm going to do, I can rename this one into as a column is going to be a sex, and I can understand if it is going to be a 0, it's a female, 1 is going to be a male, correct? The same way I can make it up this one, because actually here, if it is going to be a female, means I'm getting 1. Wherever I'm getting this value, that's going to be 1. Instead of that, what I will going to do, 0 or 1 in the straight row. See here, I'm going to change this one. I'm keeping only the male row, right? 1 0 0 1 0. Automatically first 4 rows, 4 males, so 3 males and 1 female and 1 male. Look at my table here, right? So instead of keeping this one, I can remove. I'm going to change this male and female with 0 and 1. And if it's going to be 0, I will consider as a female. If it's going to be 1, is going to be a male. So that what I'm doing after creating this series, right? I'm going to drop the row, first row. That is nothing but the female row. I'm going to keep this one for male row. Okay, sorry, just I removed that female row, so don't think in different way. Just I want to make sure that 0101 combination. That's the reason, right? After this, what I'm doing here, I want to change the header name. Here it's like the mail. I want to change the name of the column header. That's the reason I'm going to change the value into proper the header for this column. I'm giving a say 6. Right now we have the one more column embarked. Embarked we have three columns, right? Three possibilities. Three possibilities. As I mentioned earlier, if you're going to change this the category variable into the dummy variable means it's going to be S C, is that Q? Yeah, Q. This is going to be like this. You remember, it's very careful, guys. I spent too much of time for this one because for your clear understanding. Otherwise, just like that, we can go ahead. Okay. So if I change this one into as a dummy variable like this, okay, what will happen? Right? Let us assume this one. After I change this one column impact, then it's going to become what? Yes, CQ at three additional columns unnecessarily. Anyways, we have a plan for that. Let me check here. So how we did for the column for sex, we made it like male and female as a 0 and 1 combination, and we removed the female column and we renamed that male column into to sex, so that I'm getting just a single column. It's going to say me for 0 or 1. So if you have a 0 combination, it will be easy for me, like a digital operations. For the same way, here I'm doing this one. So I'm getting the structure like this. And again, what I'm going to do, I can remove this. So if 0, Q is equal to 0, S is equal to 0, then value is going to be a C. Right? So that what I'm doing here, if it is going to be both are going to be 0 means C is equal to 1. Right? So what I'm going to do, I'm going to remove that set of column, then I can have just only one. The same way, I don't want to go into detail. Probably you can try it yourself. So print that value. The same for P class, passenger class. So I have a passenger class 1, 2, 3. So the same way, I'm creating a separate column called embarked and P class. So I'm getting this one. For P class also, I'm removing that one column so that I'm getting it 2 and 3. So both are 3 means obviously class 1. This is a class 2. This is a class 3. And this is a class 3. And both are 0. So obviously that's a class 1. So try to understand the logic, because I want to accommodate that field as well as same time I want to change the name. Okay. So after that, what I'm doing, I'm going to merge all my series into my given data set. Okay. So like this. 1 minute. This is my existing data set. Data set should be yes. Okay. So this is a new column. This is another new column, and existing one. I'm merging with this so that I used to get this one. It's very, very important, guys. That's why I'm taking too much of time. So please bear with me. So I'm getting all the data set along with my two columns. Okay. So that I'm getting this one. So now what I'm going to do, already I I have my column like for male or female or and my embarkment and as well as my class. Okay, so I can remove that, rename this column, and then I can remove the unnecessary columns. So finally, I used to get the column like this way. Look at here. It was earlier like this. See, Mhm. Look at here. How it was earlier. Now, before this one, just I want to make sure the confirmation. Mhm. It's really challenge. It's a very important steps here. Look at here. It was like this. Now this is like this. Which one is better way to do the analysis? Tell me now. Because I don't know the name. I have removed all the names and all. Unnecessary names and all. I removed all the stuff. Data cleaning. And I dropped my given 6 column and embarkment, name, ticket, passenger's ID. This and all not at all required for my analysis. Do you agree? Right. Because I don't know anything. Just I want to make sure that the fare detail and all the data, right? So it will be easy for me. See, look at here. Got it? So now my analysis will be easy. So if I apply my model here, then it will be easy for me to get the output properly instead of this one. If you're applying raw data, if you're applying here, then definitely I cannot do that because it's a string, and here also this is also string, and I don't have any. There was some blank data was there, and I don't want to. I don't want this this column, right? Passenger's ID and then name. I don't want this. So everything's removed. Then finally, I'm getting what? This data. Now the table, my data set is ready for to do my analysis. Till then, any doubt, guys? Here I want to have only the surveyed. I have how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns here with a simple 0 or 1 combination. So it is easy for me to do the analysis. So what I'm doing, I'm dropping for this specific statement only surveyed. Surveyed column I'm removing so that from P class into until then I'm getting what all the data for my X, and just surveyed column I'm giving to Y, right? And I'm splitting my row. What is that? My going to be a train and test things. So I'm applying my logistics simple way. Directly I'm fitting that, and I'm finding the logistics like model score is going to be what? 81. And for this one, train data is going to be 81 and test data is going to be a 77. So how we got this detail means because after we removing all other unnecessary column and make sure that all the data in 1 0 combination. If you're not changing any data, like if you keep this one, if you keep this one as yes 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 and male or female, male in a text format, and passing all this detail like passenger's ID, survey, passenger's name, fare, ticket, fare, etc., etc. If you apply all the column here, if you apply all the column directly, your output might be indifferent. You are like the score going to be definitely lower than this. So because actually we have changed it, because internally the system will take care of all the columns into the account and doing all the analysis and giving the output. Don't think too much how internally it is doing all those things. If you want to do that, you need to jump into mathematical analysis, how internet is doing, so that you can come up with the idea how we did it for uh, this one, how we did this for, right? So you guys are supposed to do this kind of analysis, mathematical point of view. You have to do all the calculation, then only you will able to get how it's become 77 percentage or 81%. Okay, and I'll coming into the next major thing, even for logistics as well. So we have uh, what is that, model evaluation. The model evaluation, so you can find out like so it's going to be a classification report. The classification report, we have three major things. So I don't want again it's like a bit deeper in that. So what I will do, I will create a videos for you guys probably after this classes, then I'll share with your ma'am, so that so you can understand that, because the detailed mathematical model we're not able to like cover in during this session. Okay, so I'll create that nice video and slides, I'll share with your ma'am. Okay, so here we have a classification report, how we did for error mean square, right? R square value in linear. The same way for logistics, we have to have the some other set of methods to evaluate that. So that is nothing but evaluation classification report. It tells us like what is the precision, what is the recall, and F1 score. As of now, just memorize this term. Then I'll share the detailed note about you. Okay, about those things. That is going to be like non-surveyed 72, surveyed and 71 percentage, like the variations. Okay, and there is a recall method is there, and F1 score is there. I'll create nice videos for this, like how to articulate. As of now, the output of our model classification report going to be for our Titanic analysis report only surveyed, not surveyed people, just 18.82.77. And here have a confusion matrix, one of the future, which is to evaluate our logistics model. There are the four columns. Okay, and we have a predicted values and the actual values. So we have a true positive, true negative, false positive, false negative. These are the major thing. So here the funny way of they representing like how the model is like what is that? It will predicting the values. Sometime the model internally it will predict error values, right? Something like that. So this guy actually, the doctor is saying like that, like you are pregnant, but if you go with this doctor actually is saying actually he's a female guy, so he's telling like you are pregnant. Basically, thing is a false positive. Okay, this never to happy happen like positive things, but it's like a false positive. And same way here is like a true negative, right? So it couldn't be definitely aligned with the statement. The same way for the false negative. So the lady is actually is already pregnant, but doctor says like predicting her she is not pregnant. So these are the actually this is the global wise like the example for this confusion matrix. There are the other few things are there. So directly how they are doing like the both conditions. The both conditions are true. Look at here like the truth table in your digital, like AND gate, NOR gate, OR gate, something like that. So the both condition, predicted value and actual values are both are same, then true positive. And predicted value and your predicted value and actual value are zero, then it's a true negative. But the rest of the two things are irrelevant. There's a error statement. Those things going to be says a type 2 error and type 1 error. Okay, this is simple understanding how the confusion matrix will work for my classification programs. So in my program as well, like I clearly mentioned each and every steps. So probably you go through that, you can understand better way how the model says the confusion matrix. So here, if I'm printing that confusion matrix, I will get the 2 into 2 matrix output, 22, 65, 25, and what is that? 27, 60. If you what is that? Add together, you will get the number. Okay. So if you want to find out the 76% means you have to supposed to add 122 plus 60, right? 122 plus 60 divided by all together. Then you can find out, you will get the answer 76. Then your model is good. Means like by using is that what happened? 1 minute, 1 minute. I'll copy this. Okay. So what I will do, I'll put my go back to my Excel sheet. Right. So what I said, 122, 122 plus 60 is one value, and 122 plus 25 plus 27 plus 60. So now 77. So my model is stable. See, after the accuracy, I figure out 77. Then I'm verifying with my confusion matrix. I'm applying compute confusion matrix on my prediction data. I'm getting the split up. So based on the analysis, 122 is a correct prediction of what is that based on this one. So true positive and true negative. So altogether in calculating, I'm getting what? My final figure is nothing but after the calculation 78%. 78% is nothing but already I have received from my prediction, where that is here, the score. The score tells about the strength of my model. Is there any doubts? It's clear. So I'll give this a separate short videos about the precision recall F1 score later on. Okay, I don't want to go deeper in that. Then that's it. We don't have enough time to cover that. Clear? Okay. So what I will do today, like I'll give some heads up on decision tree and random forest. So probably we'll go theory. What is that? The coding part we'll see it on tomorrow. Decision tree and random forest is very simple. Okay, like what is that? The creating your um, bubble sort and your sorting algorithm, what you are used in your programming, right? So similar way, right? So the decision is going to be used for classification regression, and in this case, actually, this is going to be like if the conditions done, then we can go ahead for the options. Like for example, I'm going to make that make decisions: sunny or overcast or rainy, right? So if it is going to be sunny, means I'm going to ask whether it's going to be windy or not. Yes, if it is going to be windy, means then I have some decision. If it is not windy, means some other decision. The same way for the other things. I'm asking like you're going to be rainy means yes. What the humidity is going to be high or normal means then I'm going to say is a high means then other condition. It's a tree structured one. Okay, right? And the random forest. So the decision and random forest altogether, it's a combination of multiple trees. There are the many trees become the forest. Probably you know the probes, right? So there are the number trees makes the forest. The same way. So if you're making a number of decision trees in your given data set, right? The given data set, and the data set becomes what? Number of decision trees becomes a random forest. So if you're going to decide any model going to be like giving a decision, whether going to be prediction in the form of random forest model, you are going to make a decision tree, and then altogether it's going to be a random forest. If you're going to be a multiple decision tree, ultimately it's going to be a random forest. This is a general statement. The trees become makes what number of trees becomes makes a forest. Simple statement. Okay, don't confuse the layman's understanding. And decision tree and random tree is the best explained together, because if it's in nature, random forest are the bunch of decision trees combined, as I mentioned earlier. When we creating and combining the decision tree, you will get the random forest with the specific rules and with the specific rules and conditions. So after creating your different decision tree, then obviously what you can do, you can merge that with the business conditions, we can make the random forest. Okay, the same for random forest consists of a large number of individual decision tree and operates in simple mode. This is how the decision trees looks like. Okay, and there are the components like we have a root node, inner node, and leaf node. It's very simple like that in our linked list, right? In the linked list, so probably I think you can remember in C programming the node the same way here, and even it has some, it pros and corners. Decision tree, what is that? Actually, it is usually not needed to be normalized or scaling the features. So how you struggling to do the all the scaling scale up for normalization for um, your linear regression, so that it will be so no need, we don't want to do anything on in your decision trees. And someone of you just note it down, so probably remind me if I forget. There are the two things I need to give to your guys. One is muting, handling the null values, and then scaling the features and feature selection, and the precision F1, F2, sorry, F1 and recall. For these things, I need to share clear detail about the separate what is that, slides as well as the videos I supposed to share. Okay, just note it down, how to handle the what is that, null values, and how we are going to do the scaling in operations in data science, and then how we are doing like a feature selection, and what is that, a classification report, detail understanding. That's very very important. Note it down, someone can remind me if I missed. Okay, anyway, I note it on myself. So I want to check whether you guys are following or not. So the four tasks are very very important when you're doing the experimental analysis and data preparation. That's very important. Okay, right. And random forest is very powerful, as I mentioned earlier, and a highly accurate model, many different problems. Um, and even there are some their own pros and cons for each and every what is that, models. So the examples and coding probably we'll see tomorrow. Okay, and these are the some high level ideas. So the picture is going to be, when you run the program, you will get this kind of pictures. Not pictures means like we'll get this kind of text. Okay, I'll show it tomorrow. Some sample nice coding. It take already too much of time. Okay, so what will happen? So after applying, you can find out the population. You can find out a number of females, number of male, and there are the 20 people are like students, and they're playing crickets like your Venn diagram, right? The same way you can split up. So your output will be looks like this, not picture inside. It looks like that the data going to be inside the your tree. Okay, so this is going to be a decision tree. This is going to be decision tree. If you're adding together, obviously it's going to be my random forest. Very simple. Okay, so see, look at here, class 9th and class 10th. How many people are there, right? So this is nothing but these are just a differentiate between like how random forest and other things. I don't discuss it now, so I'm stopping here. Any questions?